Where are we going in terms of the drinks or? It's, I think it's a Tribeca tab bar or something. No, I think, one of the advantage of being last is that everything that I want to say is already said, so I don't have to say much. But what I want to bring is maybe I think we talked about quite a bit of where we are, and wanted to give you a context of Ericsson, and I'm sure it is also true for many other organizations in terms of how do we make this AI real, and what are the challenges from the data and model point of view that we are looking at is what I would like to spend some time on. This is a game here. So.
No, that's the pointer. It's this bottom button. Sorry.
Yeah. Okay, maybe I'll just use that.
Hang on.
Yeah, okay. So I wanted to give you some context of the problem that we are, or the opportunity that we are trying to address, and how we want to look at AI and machine learning from that perspective. Hopefully this video will play here. Let's see.
This is our logo. This is our founding father. This is a connected streetlight we co-designed. It can monitor weather, air quality, traffic, and lots of other things that make cities smarter. This is Bluetooth, which we invented. This is us, leading the way towards 5G. And these are some of the other 39,000 things we've invented that have been crucial in making communication and the internet fully mobile. How did we manage to do it? With knowledge, over 140 years of experience, and a lot of hard work. For instance, this is how much we've invested in R&D the past 3 years. This is a tablet we designed 10 years too early, and maybe too big. This is a router that can bring connectivity to an entire city. And this is the number of mobile subscribers supported by us. 40% of all mobile traffic in the world runs through networks supplied by us. But that's just the beginning. Our vision is a network society where every person and every industry is empowered to reach their full potential. Like these folks and their 17 million container fleet that we connected. And this small event you might have heard of, where we enabled 3.4 million people to share massive amounts of data live, but also the 500 TV channels we play on, reaching more than 500 million households. And this car, which uses our cloud to make driving safer and more fun, the thousands of families we're helping to reunite, and all the children we connect to education. No matter whether it's people, industries, or society, our mission is to lead transformation through mobility. We do it with the help of Munvi, Christian, Cliff, Azra, Krishini, and everyone else in more than 180 countries, where we innovate, perform, and partner on a daily basis. With the power of 5G, cloud, and the Internet of Things, we continue to empower people, transform industries, and advance communities. Welcome to the Networked Society.
So the point I wanted to make with that video is the type of systems that we are looking at are real time, are mission critical. So we are not talking about serving advertisement here, right? Or finding dogs and cats. So that's not the AI that we are looking at here. We are looking at a highly complex system. And what I want to talk about next, I want to show just one more video to talk about how we are trying to make the systems quite easy in terms of the design, in terms of the usage, and in terms of the maintenance of the system. So let me just kind of briefly, will it be here? So this is, you saw the complexity that we are dealing with and the challenges that we have. And this is basically how we want to address those challenges moving forward. So it will give you the context of what I mean by making AI real when I talk about
Over the years,
challenges.
We have connected billions of people. We have laid the foundation for innovation and growth, and we have brought it everywhere. But this time, it's different. Now, our IoT, 5G, and automation technology stands ready to unlock a wave of new value. We're talking operating rooms connected across oceans, trucks communicating to increase efficiency, and factory floors going fully digital. We'll see waste reduced, accidents dramatically decrease, and remarkable new business models come to life. But we're getting ahead of ourselves. To make this a reality, we're on a quest. To make technology easy to use, adopt, and scale. To build an ecosystem together with our customers where change is easy, where standards are global, and where the full value of connectivity can be realized faster than ever. Getting to easy won't be easy, but we're determined to lead the way, to move fast, to knock down barriers, and to cut through complexity. Join us.
So that is the problem that we see when we are looking at making AI real, is this making this real-time system and the complexity and the ease of use. Today, that is taking lots of people, lots of brittle systems that are running on heuristic-based algorithms and approaches. And that is not what is sustainable moving forward. And I'm sure this is the same challenge for many of the other industries like healthcare and others. So the opportunity that we see from the AI and machine learning point of view is on three different fronts for many of the industries like ours. First is the automation. The current operational systems that we have, how do we automate them? How do we make them more efficient and effective? Many of the systems, as we saw it, it's not that we are the sole owner of that experience. For example, we are not like Google, where you own the search. So the entire system is under your control. When we develop these products and when we deploy them, like with AT&T and others, we have to work with our customers. We have to work with their customers in the 5G world as we see it, because this networks and what we provide will be used by many others, not just by ourselves and by the consumers as the primary interaction point for us. So we need to deal with the operational system that we have today and how do we automate that using AI and machine learning. We are also looking at the evolution of the products like 4G, 5G, and making this evolution coexist. So you have to deal with the complexity of dealing with multiple different versions of the systems, and that also has implications in how do you deal with those kind of multiplicity when you deal with the AI and machine learning aspects. And at the same time, we are looking at growth in terms of creating new businesses using AI and machine learning as a way to either make our networks and infrastructure that AT&T and others develop to be used by healthcare, by utility, and by other industries. So how do you create new growth businesses using this one? So to do this, machine learning and AI, and when I talk about AI, I think many times the machine learning that we have talked about so far is mainly data-driven systems that we are talking about. In the context that I was talking about, we are also looking at cognitive systems that sometimes IBM talks about as well. So it's a data and knowledge-oriented systems that needs to come together. And that creates more challenges that we need to support with the systems like Ecumos or the environment that we are creating with it. So what we are looking for is intelligent products and services. So AI and machine learning is at the foundation of these products and services. One of the challenge with these products that we have, that we develop, is this products stay in service for decades. So this is not your typical data center marketing environment where you can just upgrade, and if something falls off, it's okay. You missed the ad, you didn't get 0.001 cent you're supposed to get, you can move on. That is not the case. Your systems are running for decades, and you need to make sure that AI and machine learning then you apply needs to be dealing with that kind of reality as you move forward. It stays in existence for a long time, but it needs to evolve over a period of time. So you're looking for this living and breathing environment and operational systems in which this AI needs to fit in now. And that is the complexity that we need to deal with. We also need to make these systems highly programmable. You saw the use cases or scenarios where the networks would be used for multiple industries at the same time, for different kinds of requirements and SLAs. So how do you make your systems more programmable and configurable without having to have human in the loop? We can't just put people in terms of how do we configure the systems moving forward. So AI and machine learning has to be part of the solution, but it needs to provide the programmability with the other two requirements I talked about before. The systems I'm talking about when I say making AI real is about real-time decision support systems. So you're not looking at batch processing system that you can give recommendations and go away like Amazon. You can get your book recommendation and that's fine. It has nothing to do with real time. Of course, you're gonna lose some traction if your recommendation is not right. Here, if your recommendation is not right, and if you make configuration changes to the network, you can create lots of issues for many industries and lose money. So implications are quite significant in terms of this kind of real-time decision-making system that we are talking about. Also, when we are trying to apply AI and machine learning to many of these systems, it is not just that you can give a prediction. You need to be able to stand behind it in terms of what is the level of assurance that you have. If your prediction is wrong, who is liable? How will you assure the liability? How would you deal with the governance and audit of your systems? So when we talk about making AI real, it is not just that you can put model in the marketplace. You need to support this aspect, otherwise it will never be real. And that's the problem that we are looking at. So the journey that we look at many of these business systems, not just for telecommunication, but even for healthcare and others, and utility and others are in the same domain, is you're going from static to dynamic to highly programmable systems and learning systems over a period of time using AI and machine learning. And this journey has quite a bit of requirements that has been reflected many times in this simplified model or the scenarios that we talk about in terms of the data ingestion, data preparation, model development, evolution, deployment, and execution. One of the things that we have to deal with in terms of some of the scenarios I talked about, that this system needs to stay in service for decades, needs to continuously evolve, needs to be programmable, needs to be configurable, needs to be adaptable, is this feedback loop that needs to keep on coming back in terms of how do we develop the models, how do we evolve the models, and how do we maintain them in the environment that it's getting deployed in. So that feedback loop creates quite a bit of challenges in terms of how do you deal with the data lifecycle. Who has access to data when and how and where, how often, and I'll talk about some of this. But I wanted to just have this picture in mind when we talk about the making AI real in terms of the challenges that we see. So it is not just that you are and again, the challenge here is that you are not having one organization doing this. So when you look at Google and Facebook and Amazon and others, they have a very well contained organizational boundary in which they try to apply this technologies. When we talk about using this technology, the boundaries, organizational boundaries and ownership boundaries changes from it's not just in one company. So data is owned by one organization, model is developed by another one, and deployment and execution is owned by some third organization. So those kind of complexity is very critical when you want to make your AI real with respect to the problems we need to solve. So the challenges that we see, and some of these things we talked about, but I'll hopefully give you a flavor of the reality that we need to deal with if you want to make this AI real and usable and commercializable. So data and knowledge challenges, and I differentiate between data and knowledge specifically because they have different requirements. So ownership of data, I think that was mentioned many times before. who owns the data. And if you can envision the scenario I talked about, the network, we build the products that builds the network. AT&T uses that product to build the network. The network is supported by us or somebody else. Our product is part of multiple products that exist in building that network. So who owns the data in this context? There is a data that is coming from our products. There is data that is generated that AT&T owns. There is also third-party data that is combined with our data to create the overall knowledge and overall view of the networks. So how do you deal with the ownership of the data, and how do you deal with the sharing of this data, not just within AT&T, but within AT&T and Ericsson and Huawei and other Nokia and other providers who are building these networks. And this is not just unique to us. If you look at the healthcare industry, it's the same problem. You have GE who is providing certain types of equipment to the hospital. Siemens is providing some other equipment to the hospital. And hospital needs to now operate and run these systems in real time to provide patient care. So you need to deal with the ownership and sharing of the data. And part of that is also now you have to deal with the governance and compliance. Who is responsible, and how do you ensure the governance and compliance of this data to make this real? And the compliance has a variety of aspects in terms of the compliance from the providers of the product point of view, providers of the service point of view, as well as the consumer of the services and products point of view. One of the critical aspects of making AI real is the auditability and traceability of the data and model. How do you make sure that data transformations are auditable? So if I provide a product to AT&T, and AT&T uses that product and changes the data and uses that data to create some intelligence and take some action, and that action has some adverse impact or even good impact, how do I make sure that it is what I'm responsible for? Who has changed the data? And this is also true when you do the transformation, when you create the features. An auditability and traceability of the additional features and data sets you create is very critical for you to understand as an organization how the data has moved, and the provenance and lineage of the data is critical aspect of doing this. And again, think about this not just within one organization. This is a multi-organizational problem because the data and models are spread across the boundaries of the organizations. Some of the challenges that we have to deal with is encrypted data. How do you deal with the data that is encrypted? And how do you do AI and machine learning on encrypted data? So homomorphic encryption that was mentioned, I think, in Susan's talk as well. But how do you how do you do machine learning and reasoning on encrypted data? And there are technologies like EncryptDB and others that are available to deal with this, but those are the challenges that we have. Mobility and locality and distribution of the data is very critical because in many of the cases like telecommunication industry, we are talking about 125, 200 terabytes of data creating on a daily basis, even more. How do you deal with this data? You can't just move it to a data center. You can't just pump it to Amazon and we'll just all go broke in one day, moving just data. So how do you deal with that kind of challenges? And of course, licensing of the data and knowledge is a critical aspect of the problem that was talked about before as well. In sake of time, I'll just kind of go through the model side. It's a similar discussion. One of the things that we need to understand and deal with is the explainability and security and assurance of the model as a delta on top of what I just talked about on the data side. So how do you make sure that your models are explainable to the humans who are going to use it, as well as the lawyers who are going to come and sue you if things haven't gone right? So without that, we can't make this operational. Nobody will use it, other than small improvements that you can do from the operational efficiency point of view. And then last but not the least, the challenge we have is at least in some of these networks and even in some of the industries, you can't move everything to a public cloud. Your data, your model training, and your servicing cannot be moved to public clouds. It will be in a private cloud or a hybrid cloud. So how do you deal with the models that can be trained in public cloud but be deployed in private cloud? And then you have to have a life cycle of that model between the public cloud and private cloud, as I talked about the feedback loop. So these are the challenges that I would say that we need to deal with when it comes to ECMOS and DLF in terms of making AI real. So I'll stop there. Hopefully I kept you awake. Thank you. Yeah, any questions? Or if you ask a question, I'll buy you a beer. No. Or if you don't ask a question, I'll buy